Hello everybody, my name is Giovani and I'm a Biomedical Information Bachelor from UFCSPA. Currently I am pursuing a master's degree at PUCRS, and today I would like to present our work, Application of HL7 FHIR in a Microservice Architecture for Patient Navigation on Registration and Appointments. First, we'll present the challenges of this work and the architectural details about which use the technologies for production and communication through microservices. Next, we'll describe how microservice and HL7 FHIR are used to perform patient registration and scheduling. Subsequently, an analysis was carried out relating the results found to those in the literature. Finally, we make some considerations about these findings. We can say that electronic health record systems interoperate when they can communicate over a common interface. To enable interoperability in the healthcare scenario, it's necessary to incorporate standards such as OpenR, ISO 13606, HL7, among others. Most of the EHRs are developed as monoliths. This approach can find some limitations with the actors involved in data exchanges, ranging from service isolation to data persistence mechanisms. Moreover, the difficulty to scale is one of the significant concerns of monoliths. These challenges can be minimized with the microservice architecture style. The continuity of care is one of the main reasons for interoperability in EHRs. As presented in the actual coronavirus pandemic, advances in data integration and public health registries have allowed an increasing number of organizations to implement faster and efficient processes for communicating with patients, hospitals, and public health agencies. Another example for a solution that requires the establishment of clear mechanisms for continuity of care is patient navigation. Patient navigation allows health professionals to guide patients on the continuous provision of care. Usually, patient navigation is expressed by three main steps. It all starts when the diagnosis is confirmed and a care plan is evaluated. After the plan is built, a navigator nurse will monitor a subset of patients accessing the EHR data such as appointment schedules, diagnoses, among others. The exit dwells at the end of the treatment or the removal of the need. Watching the daily workflow of healthcare professionals, Paultausen and collaborators identify requirements for developing a patient navigation system for oncology patients that needed interoperability with existing EHRs. In other words, existing data could be reused and supplemented when necessary. Modifying current systems to include new processes such as patient navigation could take time or resources. Employing interoperability standards can perform these reuse mechanisms. The HL7 FHIR allows data exchange among different EHRs in a standardized way. For example, common EHR data like patient registration and scheduling can be exchanged between EHRs using services in which of its components are made available as resources. So our goal was to develop a prototype based on a microservice architecture that incorporates HL7 FHIR as an interoperability strategy simulating a real context patient navigation approach. Considering HL7 FHIR in isolation may help solve some health data communication interoperability issues. We cannot guarantee the solution of issues common to monoliths. As already described in a recent study, common monolith issues might be overcome with microservices. A microservice architecture style is an approach to developing a single system as a set of small services running its process and communicated with lightweight mechanisms, usually application programming interface of HTTP resources. Considering data exchange among microservices and FHIR, there are two possible scenarios: synchronously and asynchronously. Incorporation of an asynchronously approach, which uses the event-driven concept as a first step, the consolidation of the synchronous approach for patient registration and scheduling. As you can see in the architectural model, this type of approach is conceived from the construction of an architecture that involves the specification of the front end and the microservice ecosystem used as part of the backend. To respect the single responsibility model, we use a chassis pattern composed of 5 subunits: login, Spring MVC, Spring Web, Spring Data, and 4 resources. The version of the subunits on the chassis rely on the dependency manager. There are two ways to integrate with auxiliary systems: REST connections to query data already recorded in the system, or accessing a NoSQL database. To directly focus on the business rules to be developed, we decided to go work with Spring Framework without implementing connections with databases or web services. So Spring Web created the REST layer and Spring Data made a relationship with MongoDB. One crucial detail is that all data were generated manually to demonstrate the patient navigation process. Finally, the REST communication exposes microservice functionalities through HTTP operations, allowing the exchange of information over the network. For this project, the establishment of communicating and data exchange is made using HL7 FHIR to simulate sending and receiving data as in a real case. The Happy Sandbox was used to illustrate how the information generated by the system will be presented for patient navigators. We developed an interface using Bootstrap. Let's see the results. We identified 4 resources for the development of the current strategy. We validate that they are enough to represent and exchange data for registration and scheduling. For each one, the patient resource includes description for the data required to create the patient record, such as identifier, name, date of birth, address, among others. Considering that the basis of for the implementation of HL7 FHIR incorporates RESTful principles for the communication between a requester and a provider, it's still necessary to include certain parts of the REST API. Specifically, it was necessary to include the bundle. In practice, the bundle provides the specification of the data that must be incorporated in the header of a JSON file used to establish the communication mechanisms. The core of our work is presented here. After defining the resources needed for the scheduling and registration, the next step is to adapt the HL7 FHIR to the microservice style. This task lies in defining a persistence strategy for each microservice. The model includes the required attributes for the microservice from a given HL7 FHIR resource. For instance, a patient microservice includes attributes such as name, identifier, gender, among others. A controller is typically responsible for preparing a data with model and selecting from the front end, but it can also write directly to the response stream and complete the request. Beyond that, the controller connects with a repository who is responsible for data persistence, and with connector responsible for the request to a FHIR sandbox. The mechanism for registration and scheduling incorporated in the solution is part of the beginning of the patient navigation. The communication established to achieve interoperability required by the patient navigation mechanism is exemplified by the sequence diagram. In other words, the navigator will be able to access the home screen, which will request the nav patient application through the get method, and this will produce a new request to the patient microservice to retrieve by means of a happy server list all the patients available. This same procedure is replicated or the navigator decides to access the available schedules. Regarding the scheduling procedure, if an event was already scheduled, the status booked is directly retrieved from the server. In our study, we applied current practices from the literature on the process of modernization for legacy systems. Because of that, we chose to implement synchronous microservices to demonstrate the feasibility for deploying for HL7 FHIR-based applications. However, this synchronous solution may result in downtime. This may be related to a high number of calls among microservices. With that in mind, the architecture behind our solution was presented elsewhere. One of the big concerns of any project is the ability to evolve. In this type of scenario, the microservice architecture fits because it allows a high capacity for evolution and a strong separation of components and a focus in the integration between platforms. On the other hand, a disadvantage with the increasing popularity of microservices related to the probability of use in situations where the costs outweigh the benefits. Our work out in details all stages of building microservices with HL7 FHIR, something that's not so accessible in the literature. However, and as I already mentioned, there is a little related literature. Even considering the benefits and the incorporation of HL7 FHIR to microservice, some difficulties were encountered. The first and the biggest was the understanding of what a microservice is and how big and how it differs from SOA. It took many hours of study to assemble the architecture to obtain deviation from the monolithic pattern. It is still a new topic for the academy considering this movement began in the industry. In this work, we present the development of a prototype based on a microservice architecture that incorporates HL7 FHIR as an interoperability strategy. When incorporated to the literature, this work fits into a strict set of few available approaches. It allows expanding the possibility of conducting new research in each only the traditional concepts are used, such as REST, but other asynchronously approach. These are the reference and details of our work, and now I would like to thank you all for watching.
Presentation for your paper. I read your paper. I think it's very interesting. Microservice-based architecture is very interesting, like in the first presentation. Then this is very interesting initiative in the healthy area. Okay, we have some questions here. The first one is from Lina. Yeah, have you used a third-party infrastructure, for example, Azure, to deploy this microservice architecture?
Thanks for the question. No, we didn't use that. We only did local tests. The other person of the group, Thafarel, was working to deploy on the infrastructure of Azure, but it was only local tests.
Okay, thank you. Elena has another question. Have you traced every entity of this standard to a different microservice?
Yes, we separated each microservice to one entity of FHIR. For example, we have the patient entity that we show on the presentation, that we separate the variables of the patient, like name, and we create only one microservice to deal with that environment of patient.
Okay, yeah. Lina has another question. How the standard is allocated in the architecture? Is it also provided as a microservice?
Sorry, can you repeat the question?
Yeah, it's here in the chat, on the chat. Oh, how the standard is allocated in the architecture? Is it also provided as a microservice? It's a question of Lina.
Yes. I don't know how to answer that because it is allocated in the. Can you send more details on the question?
Because this standard has many different parts, and I think Lina is asking about how you mapped this standard into the architecture. I think this is the question, Lina. Lina, could you elaborate your question in the easy way to Giovani to understand better? Yeah.
Yes. So we mapped the FHIR specifications, like working on a collaborated way with some nurses on a hospital here in Porto Alegre, Brazil, and it can be it was difficult to understand what FHIR can integrated us to map the patient navigation approach into the architecture that we are trying to create. And HL7 FHIR, it was allocated in that way. We cannot we try to establish a basic study, but it was only theoretical. It was not it's not something like we didn't go to the production on this way.
Okay. Yeah. Elena has one question for you. Don't you think your architecture could be compromised by exposing direct to your microservice instead of using a typical pattern such as API gateway?
Yes, yes. Like I said, this architecture was only created for studying purposes. It was not only created, but for deployment and production consumption. Um, uh, the other the other person on this group, Thafarel, we are trying to create and replicate a more complex architecture for creating a more secure environment to production and deployment tests.
Okay, yes. I have other questions from the audience, please. We can put there in the chat. And I think I will use time to do some other questions here for you. Are there similar solutions that try to transform legacy health system to microservice-oriented architecture?
In 2021,
Yeah, do you know about other solutions try to to modernization of legacy system in the health area to microservice?
um, I didn't know more other solutions that enable the modernization of legacy systems because the this work was only for my undergraduate on biomedical informatics, and I tried to continue, but the pandemic situation stopped the study because one of the main hospitals that were our partner stopped the activities because they have more urgent situations to deal with.
Okay, yes. Elena has another question. She said, we have also developed an architecture for supporting this standard, but using other typical MS patterns. It's more complex, but provide additional benefits. Would you like to comment about this?
You created a microservice patterns in 2021. You can I think that a more complex infrastructure and an architecture is needed. Uh, that 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 we are created we created a study because when do you when we started uh, working with microservice, we cannot achieve um, more we cannot achieve more details about how can we create and maintain a microservice because it, it wasn't so clearly in the literature. But I think that yes, uh, we needed more patterns and more description on literature. I think it provides, yes, additional benefits.
Okay. I have another question. We have time for that. Before implementation of this system, you design the architecture, yes? You design
Yeah.
the architecture before the implementation, yes?
Yes, we design.
Yeah. And this architecture was, to some extent, for instance, trying to check if the number of microservices are okay, is okay, or the communication between components in this architecture is correct, or the architecture is according to this standard. This evaluation was conducted or only think about the architecture and implement it directly?
We cannot validate it, the architecture in this particular job, because we are conducting new studies of this architecture in another project, and these validations will be presented in this another project.
Yeah, this is very important to validate the architecture before implementation. Then that time during the validation, it's possible to see problems in the architecture. I think in your architecture you have only 2 microservices, yeah? One for patient, another for appointments, yes?
Yes.
Yeah, maybe it's interesting to think for the future to in the way to break down this microservice in microservice. I think this microservice is very large at the end. Yes, maybe it's interesting to break down this microservice in other small one. Yeah, maybe it's interesting to do to have a more modularized system for the future. Okay.
Okay.
And after implementation of the system, this system was this system evaluated or only discuss about this implementation? Because I think in your paper we don't have evaluation of this implementation. So it's correct?
Yes, it's correct. We compare our work with the literature, if it fits the approach of microservices. But yes, we are going to it's the next step of our job. We envision testing this approach in a production environment, but in order to evaluate how the architecture behaves and support a proper healthcare setting coupled with a HL7 FHIR production server, for example.